In segments 1 and 2, you learned why to do CEAs and how to compare net costs to health outcomes. In segment 3, you learned about DALYs and QALYs, the Uber health metrics. In this segment, number 4, on CEA Results Tables, we examined CEA findings and how to present them. Now, let's talk about how to present findings from a CEA. We'll start with a standard CEA Results Table for just 2 intervention options. We have no therapy and drug A. In this case, we say that the evidence suggests that for a person with this unspecified disease, the net cost with no therapy is $10,000, perhaps representing a 20% risk of being hospitalized at a cost of $50,000 when it happens. There are 4 DALYs associated with this disease. That means that the person with this disease will suffer a total of 4 DALYs representing both premature mortality and morbidity, compared with the person without the disease. Drug A increases the net costs. Maybe the drug itself costs $4,000, but it may reduce the risk of hospitalization, so the net cost is $12,000. And the DALYs decrease from 4 to 3.5. Maybe there are both small morbidity benefits and a slightly extended lifespan. In this table, we calculate the differences in costs, DALYs, and the ISER. Under delta cost, we see that the difference in net cost is $12,000 minus $10,000, or $2,000. So drug A costs $2,000 more than no therapy. The difference in DALYs is 0.5, simply 4 minus 3.5. This means we can calculate an ISER, a net cost per DALY averted. It works out to $4,000. Depending where you were working and which standards you use for cost effectiveness, that might be considered either very cost effective or cost effective. People always ask, what's a good ISER? And that depends. Currently, the World Health Organization, or WHO, specifies an ISER below the local annual GDP per capita as very cost effective, and below 3 times the local annual GDP per capita as just cost effective. A more sophisticated approach is to look at all of the options and pick the set of interventions that are truly the most cost effective. That may eliminate some that are cost effective by WHO standards because they're just not as cost effective as other choices you've got. You might wonder, what happens if you have a negative ISER? Well, in this example, we've added drug B. And look, drug B is more expensive. Maybe it's a new drug. The net cost is $17,000. That might be okay, except if you look at the DALYs, they went down from no therapy to drug A, but went up to drug B. In other words, drug B doesn't work as well as drug A. So you might think, well, that's an ISER of negative $20,000 per DALY averted. But that would not be correct, because once you have a negative ISER value, you don't actually show it. It doesn't have any technical meaning. Unlike a positive ISER, which represents the cost of gaining health, a negative ISER changes values in odd and non-intuitive ways as you alter cost or DALY inputs. Until you go through that exercise yourself, you'll have to take my word for it. Negative ISERs should not be reported. So what do we do instead? We use the word dominated. Drug B is both more expensive and less effective. So drug A dominates B, or drug B is dominated by drug A. It's cheaper and better. There's no need to compare the added costs to the added benefits. Now let's look at a table with more comparisons. We've kept drugs A and B and added drugs C and D. In this example, drug C has a higher net cost, but it also works a lot better. Drug D has a still higher cost, but it doesn't work as well. So what we have here is 2 strategies, A and C. Both have positive ISERs, $4,000 for A versus no therapy, and $6,000 for C versus what? What do we compare C to? Normally, in an incremental CEA, we compare each option to the prior option. But B is dominated, so irrelevant. Instead, we skip to the closest viable option. We compare C to A. Notice how we're comparing each option to the next least expensive option. We're not comparing each option to the cheapest option at the top of the table. The way I like to explain incremental CE ratios to my students is by reference to my children's desire for a fancy sports car for our family. They want me to spend $100,000 for a car. I tell them, yeah, that sounds like a good car and a lot of fun, but I have a Volkswagen and it works fine and it costs $25,000. And for me, the comparison isn't the $100,000 car versus no car. It's $100,000 versus the VW. It's all incremental. The same strategy and technique applies here. So if you're going from no therapy to A, that's $4,000 per DALY averted. Remember, you don't compare to B because it's dominated. Drug C is $6,000 per DALY averted compared to A, and D, again, is dominated. Now what if you find that drug A actually is impossible? You can't do drug A for some reason. Maybe it's under some restrictive patent. Then you can compare C to no therapy, and drug A wouldn't even appear in the table because it's not a viable option. That's all for CEA results tables. All of the results are referred to as base case, with the best estimates for input values. However, we know there's uncertainty because we never know each input value with complete precision. The value may have a 95% confidence interval in the source study or imperfect applicability to the modeled study population. That's why we head next to sensitivity analyses.